Hello friends, welcome to online lecture series. Today we will just see the another application of differential equation which is very useful in your mechanics. So today's topic is application in mechanics. So let's start today's topic, the application of your differential equation in mechanics. So we should know what is the mean by velocity, what is the mean by acceleration, and what is the mean by displacement. So basically we know all these particular concepts, acceleration, velocity, and displacement. So we will just start the first topic in application in mechanics, rectilinear motion. The first we know what is the mean by the rectilinear motion. The rectilinear motion is defined if the particle is moving in a straight line, then the motion is called rectilinear motion. So the definition of your rectilinear motion is the motion of the body or a particle along a straight line is called motion of rectilinear motion. It can be explained with the help of this diagram. Suppose the particle which is situated at point O, or the particle is at point O. When we applied some force on this particle, the particle is moving along this OP or along this x-axis in a straight line and reaches to the point P. The total displacement of this particle is x, and the mass of the particle or mass of the body is suppose m, and F is the force which is applied on the particle. The particle place its position from O to P. So we said that the displacement of the particle is x. So when we say that the particle of mass m moving along the x-axis starting from point O, then we get the displacement of your particle is OP, and P is the position of the particle at time t, and OP, the distance is x. Then we can define some terms, that is velocity. The rate of change of your displacement with respect to time is nothing but my velocity. So the velocity is v equal to dx upon dt, where my x is my displacement which changes with time. So we get the velocity value in terms of displacement, that is a dx upon dt. The rate of change of your velocity with respect to time is nothing but acceleration. So a is equal to dv upon dt, and value of your v is dx upon dt. When we replace the value of your v is equal to dx upon dt, so we get the acceleration in terms of displacement in terms of d2x square d2x divided by dt square. Also, we can define this acceleration in terms of velocity and displacement by changing the velocity with respect to time by using the chain rule. So dv upon dt can be written as dv upon dx, and dx upon dt means we are separating this dv and dt by dx. So we know that this dv dx upon dt is nothing but by v, and this dv upon dt remains as it is. So we get the velocity of the body is dx upon dt, and we are replacing the value of the dx upon dt is simply v, and the dv upon dt remains as it is. So we get the acceleration in terms of velocity and time. And we know that Newton's second law of motion, the rate of change of momentum of a body is proportional to the resultant force acting on the body. So mass into acceleration. This is nothing but my acceleration. And the acceleration can be replaced with the help of velocity, and it is dv upon dt is equal to the net force which is applied on the body. So according to the Newton's law, the D'Alembert's also state that D'Alembert's principle, the algebraic sum of the forces which is acting on the body along the given direction is the product of mass and acceleration. Means again the same law is applied here by the D'Alembert's. He said that the total or the net force which is acting on the body is nothing but mass into acceleration. So this is the formula of the D'Alembert's. Ma, mass into acceleration. This A can be defined with the help of displacement and time. d2x upon dt square is equal to the summation of all the forces, or is said to be the net forces. And the thermal velocity is defined as when we just reaches the maximum time, we get a thermal velocity of that particles. Limit t tends to infinity of v of t. And next topic is my simple harmonic motion. A particle is said to be simple harmonic motion if its acceleration is always directed towards a fixed point. Means that any particle whose acceleration is tending towards or directing towards a constant point, then the simple harmonic motion is there. On the line and the various as the distance from the fixed point. This is the concept of your simple harmonic motion. See here, the A is the point, A dash OPA means OPA is the final length or the final displacement. Suppose O be the fixed point on a straight line. P is the position of the particle at any time t. Then OP is equal to x, and V can be expressed dx upon dt. We already stated that. And this d2x upon dt square is equal to minus times kx, because it is going towards origin. Or the V dv upon dt is equal to minus kx is the value. So we can define some notes note here. The differential equation of the simple harmonic motion is d2x upon dt square is equal to minus omega square x. Or simply this shifting this minus omega square x to right hand side, we get d2x square upon dt square plus omega square x is equal to 0 is a differential equation of simple harmonic motion. The periodic motion, simple harmonic motion is a periodic motion with the period, and the period of the simple harmonic motion is 2 pi upon k, and the frequency is nothing but the 1 upon period. The frequency is equal to root k upon 2 pi. Third important note is the maximum displacement on either side of O is called amplitude. Means we have to just find the maximum distance from the point O is on the either left hand side or the right hand side. It is set to the amplitude. The maximum acceleration when velocity equal to 0. When the velocity of the particle is 0, then we got the maximum acceleration. These are the 4 important notes. So we will see one example of this. A body of mass m falling from the rest is subject to the force of gravity and an air resistance proportional to the square of the velocity kv square. If it is falls through a distance x and possesses a velocity v at a distance at any instant, prove that 2kx upon m is equal to log of a square upon a square minus v square, where the value of your mg is equal to k times a square. So we get the condition here. For that, we have to find the force which is acting on the body. The force acting on the bodies are two different forces acting on this body. The first one is resistance due to the air, and its force is minus kv square. Why it is negative? Because the force of this air opposes the body of mass which is falling from the rest. And second force is force of gravity, that is mg. So with the help of this figure, we can just say that suppose the body is at rest, and we are just falling that body from topmost to downward. The total distance is x, and the force acting on the particle is suppose mg, and some external forces, that is a kv square, which is in upward direction. So the force acting on this body, that is the air force, which is opposing the body to falls down from your top. So therefore it is becomes negative. The total net force acting on the body is the Newton's second law of motion, or we say that by D'Alenbert's principle, we say that the force is nothing but mass into acceleration. And value of your mass is m, and a is my acceleration, that is a, and f is the force or the forces acting on the body. So m is the mass, and the acceleration is expressed in terms of v dv upon dx, and the forces which is acting on my body is mg and minus kv square. So the value for mg is equal to k square. We replacing the value for mg is equal to k square. We get m times v into dv upon dx is equal to k a square minus kv square is my differentiable equation in v and x. So taking k common on right hand side, we got mv dv upon dx is equal to k times a square minus v square, and making the variable separable form, separating the variables on both the sides. The left hand side should contains v and the right hand side contains x. Taking the integration, we get a solution for such a differential equation. M is constant, which is outside your integration. Remaining is a v times dv upon a square minus v square is equal to k integration dx. And we have to use this formula. The integration of f dash of x upon f of x dx is equal to log of f of x plus c. When we just observe here, the function f of x is equal to a square minus b square. When we differentiate this function, we get 2v. The 2v is not present in my numerator, so we have to make the adjustment of v2 on your numerator and the denominator. So differential equation solution becomes minus m upon 2 integration minus 2v upon a square minus b square dv is equal to k integration dx. On the left hand side, we get minus m times m upon 2 times log of a square minus v square, and the right hand side is kx. To find the value of your constant of integration, we have to put the initial condition at x equal to 0, the velocity is 0. So the value of your c can be calculated replacing the value of x equal to 0 and v equal to 0. So minus m times m upon 2 log of a square minus 0, because the value for v is equal to 0. On the right hand side, x equal to 0, the c is equal to, we got c is equal to minus m upon 2 log of a square is the value of your c, and we have to put this value of your c in equation number a. So we get minus m upon 2 log a square minus v square kx minus m upon 2 log of a square log minus m upon 2 taking outside, log a square minus log a square minus b square. According to rule of your log a minus log b is equal to log a upon b. So we get the final solution of this equation. In this way, we can find the solution of the body is that is 2kx upon m is equal to log of a square upon a square minus b square is the solution for our equation. Thank you.